Hello, friends. Hope you all are doing good. Welcome to BreakFX program, Insight Fellowship Program in Advanced Analytical Problem Solving Expertise, APEX, and we are almost on the verge of ending with our first certification. That's about Six Sigma Green Belt. We are in a control phase. That's the very last phase. So let's go through the recap one more time to solidify our understanding about this problem solving methodology. So I'm Santosh Gnaneshwar Sarkar. Let's go to next slide, please. Right. So we started with the define phase where we try to find out different problems for the organization. Just a moment, let me take this point. Right. So, we just had a word with operations. We, in the sense, you're going to have word with operations, and you're going to check out, what are different metrics they are maintaining in process and try to find out different probable problems. Once that is done based on operational level diagnostics and FMEA, you will prioritize the problem. So that is very important aspect of define phase. First of all, listing down the probable problems and then prioritizing the problem. Once that is done, of course, very next thing is you're going to quantify the problem and set the improvement goal. By the end of the day, you want to reduce or fix the problem. And for that sake, we got to have a goal. So you're going to do that, and you're also going to document it with the help of project charter. Then once we finalize with what is the problem to work upon, we are going to find out where actually the problem is lying or locating in a given process. So that's with the help of high level process map. So in define phase, we define what is the problem and where is the problem. Then we enter into measure phase. In measure phase, of course, you define how are we going to measure the problem. So you're going to attach the measurability characteristics under performance standard documentations, right? So that's where you will do. Then listing out probable causes that would lead to problem, right? So if you want to solve the problem, you got to find out what are probable causes and need to work on those causes. But we cannot work on all of those causes, and that is why we need to prioritize the causes. The first level of prioritization with the help of CR matrix, where from this list of probable causes, you will finalize and segregate critical causes, the causes which are highly controllable, highly severe, and of course highly frequent. So once that is done, then you'll go ahead and collect the measure phase data for project Y and that for a critical causes. That's a measure phase data collection. Then after that, once you got this project Y, you're trying to find out how critical is the problem, right? So you're going to measure that as well. So with these two steps, listing down probable causes and selecting critical causes, you measure the criticality of the causes, right? So this is what you have done or you're going to do in a project. And then you also need to measure the criticality of the problem as well. That we're going to do it with the help of capability analysis. So that's what we did in a define and measure phase. Then we entered into analyze phase. So that's the next level or second level or advanced level of prioritization with the help of statistical foundation. So statistically, we are going to prioritize significant few causes from critical many causes, in analyze phase with the help of chi-square test, goodness of fit test, graphical assessments, right? That's we're going to do it. And of course, we had a couple of strategies, strategy 1 and strategy 2. So I'm not going to get into it. But all we're going to do in analyze phase is statistically prioritizing significant few causes from critical many causes, right? So when we started, we had, take an example, more than 20-25 different probable causes, right? Then at the level of critical cause finding or selecting critical causes with CI matrix, we trim down the total number of causes to say 8 to 9 different causes, and from 8 to 9 different causes, we're going to find out statistically significant 3 to 4 different causes. So you can imagine from 20-25 different probable causes, you figure out 3 to 4 most significant causes which do have relatively higher impact on our problem. So if you could work on these particular causes, in other words, if you could fix these causes, that will definitely have a relatively higher impact on a problem. So that's the foundation of our philosophy or thought process in a Six Sigma. So once that is done, then we'll enter into improve phase. Now, post analyze phase, we do have statistically significant causes. Now we need to find out the probable solutions for it. We cannot work on all the probable solutions, so we need to further refine it, with the refinement tool. And we are going to use four different scanners, if you could remember: impactability, cost effectiveness, then feasibility of implementation, and finally whether can we get client and senior management consent to deploy this given solution. So on that basis, you're going to prioritize potential solutions from the list of probable solutions. And the very next thing all we're going to do is we're going to develop a solution implementation plan, because those solutions need to be implemented for a short period of time because we want to test those solutions. So on an experimental basis, you're going to implement those solutions under pilot deployment. So pilot deployment is all about deploying the potential solutions on a short-term basis. Then once that is done, we're going to collect the data for improve phase as well. The way we collected data from measure phase, here as well, we're going to collect the data. But we're going to collect the data only for project Y, right? So that's what we're going to do. Why we are collecting data? Because we want to validate whether the solutions which we have implemented have really brought brought that improvement. That's what we just look out from this particular data. So we are going to collect the data in improve phase, and then of course we're going to use 2P test to validate whether we have improved over major phase or not. So here we're going to compare this major phase data. Where is that data? Yeah, this data. We're going to compare major phase data with that of improve phase data with the help of 2P test, and try and validate where we have improved by deploying those solutions. Once this is done, then we'll go ahead and try to find out the capability of an improve phase as well. Have we improved the capability? Is sigma score improved for an improve phase over the major phase? So here we have capability analysis for improve phase. Likewise, here the way we had it for a major phase, right? So the major phase capability analysis, where we were standing before improvement, and this is where we are standing currently after improvement. So sigma score is supposed to be improved over major phase, and to prove that, we're going to do the capability assessment. Of course, we do have a couple of indicators, that is ppm, parts per million, and second is of course sigma score. So that's about finding the capability for improve phase. Then we are going to modify the current process map with updates. Updates means the solutions. So henceforth, when team is going to implement these solutions for ongoing purposes, they need to know where to implement those solutions, for which step they are going to implement these particular solutions. So that's why we're going to modify the current process map, and hence the team is going to implement the process map with these additional activities or with these solutions, which we have proven that improve the project wide, right? So we're going to modify the current process map with updates. Then we will enter into control phase, where we're going to prepare a control plan to monitor project wide for a long-term basis or ongoing basis, right? And control plan to have monitoring plan and response plan. Then once we have passed over the task to be taken care, to operations team will continue monitoring the performance of project Y henceforth, right? So all Six Sigma green belt supposed to do is, he or she is supposed to visit operations once in a week, try and collect the data of project Y on a weekly basis for next 6 to 7 weeks. And then once that data is collected, of course, the very next thing need to be taken care, is we need to plot P chart to see whether the performance of project wide stabilized or not. And for that sake, we use P chart or control chart. So that's about the plotting the control chart. Here, since we are going to plot number of, we are going to plot the proportion of defective, that is number of defective shifts divided by total number of shifts in a given week. That is our one proportion, that is our one data point. And for 6 to 7 different weeks, we're going to have 6 to 7 different data points. So when we are going to plot this proportion, right? So the control chart which we are going to use is called P chart. So we already talked about this. Now we're going to enter into next step, and that is comparing improve phase project Y with that of control phase project Y, because we want to prove that improvement is sustained or improvement is stabilized in a control phase. We already did this comparison in an improve phase, if you could recall. We compared pre-improvement project Y versus post-improvement project Y to validate whether we have achieved improvement by deploying the solutions from here, right? Now, in control phase, we need to validate whether improvement is sustained or improvement is stabilized in a control phase or not. And that's where we're going to compare improve phase performance. This is what a data we have, improve phase data. So we're going to compare the performance of the improve phase with that of control phase. All we need to prove is that in control phase as well, we sustained or we stabilized the performance of the improve phase. The performance has not been reduced or worsened in control phase. It's continued or it's sustained, it's stabilized. Improve phase performance is stabilized in the control phase. And to do that, we also going to use statistical analysis. And for statistical analysis, we're going to use 2P tests. So all these things we're going to look into in this particular video, 2P test, how to deploy 2P test for control phase on a next few slides. So let's move to next few slides. So control phase, step number 5.3, right, validating improvement stability. So after starting deploying solutions on a long-term continuous basis in control phase, of course, we need to check whether improvement is stabilized. In other words, we need to check whether problem is fixed permanently or not, because that's what the ultimate goal of following this Six Sigma problem solving methodology. That is why we need to validate that improvement stability. So let's go to next slide and understand it a bit more. Right, so validating improvement stability. To validate whether improvement is stabilized in control phase, one need to compare proportion of NC, that is non-compliance of control phase, with proportion of NC of improve phase, like we did it in improve phase. Right, so in improve phase, we compared pre-improvement NC with that of post-improvement NC, that is major phase NC and improve phase NC. Right, NC means non-compliance. Here in control phase, we are going to compare improve phase NC, that is improve phase non-compliance, with that of control phase non-compliance. And all we need to prove is improve phase non-compliance and control phase non-compliance are almost standing at the same level. In other words, in control phase, we have not increased the number of NCs, right? That's what we need to prove. Why we are asking this? Why we want to check this? Because in improve phase, we implemented solutions on a short-term basis, experimental basis. That was the experiment. But when we are going to deploy the solutions on a large-term basis or long-term basis, there are definitely possibilities that performance might get shaken, or in other words, performance might get worsened. So we need to prove that no, performance has not been deteriorated. Performance is sustained, that is improvement sustained over the period of time in a control phase, even after handing over the responsibility to monitor the performance or to deploy the solutions to the operations team. We have handed over that responsibility to the operations team, right? So here, you as a Six Sigma Green Belt need to validate it. And how are we going to validate it? We're going to validate it with a two proportion test. So let's go to next slide and understand it in much detail. So improvement stability in control phase. So here we are having two separate samples, Y1 that is improve phase PT non-compliance versus Y2 that is control phase PT non-compliance. Now what is our hypothesis? Our hypothesis has improvement stabilized in a control phase? That is proportion of PT non-compliance of control phase is same as PT non-compliance of improved phase? That's what is our hypothesis. And what is our H naught? That is a null hypothesis. Proportion of PT non-compliance of control phase is same to proportion of PT non-compliance of improved phase. That is, improvement is stabilized in a control phase. Yes. So when number of non-compliances, or for that matter, the proportion of the non-compliances in a control phase, if it is going to be equal to the proportion of non-compliances in an improved phase, it means performance is sustained, improvement is sustained. So that's what we're just looking out for. And when improvement is sustained, in other words, improvement is stabilized. So that's about our H naught. We do have a HA, that is alternative hypothesis. Proportion of PT non-compliance of control phase is higher than proportion of PT non-compliance of improved phase. That is, improvement is not stabilized in a control phase. So this is our alternate hypothesis. So we are showing right now the case of PT non-compliance, but to validate improvement sustenance or improvement stability for any other project, this is what our hypothesis you got to put it over there. So these hypothesis statements are quite standardized. You got to follow the similar way for any other projects. Yes, in control phase, we favor null hypothesis as we want to prove control phase performance is same as improved phase. Hence, we expect p-value should be more than 0.05 for 2p test in control phase. So for rest of other tests, like chi-square test, for that matter, or even 2p test in an improved phase, we were expecting or we wanted p-value to be less than 0.05, for that matter, less than 0.1. But here in control phase, please do remember, since we are favoring null hypothesis, why we are favoring null hypothesis? Because we want PT non-compliance of the control phase is remaining at the same level as that of improved phase, which is our null hypothesis. So we are favoring null hypothesis, and hence we are looking out for, or we are expecting p-value to be more than 0.05. So in this particular test, for that matter, for improvement stability validation sake, we are expecting p-value to be more than 0.05 and not less than 0.05. So please do remember this. Let's go to next slide and testify. So here we do have a data for improvement stability in a control phase. If you could recall, we also have clubbed improved phase as well as the major phase data into improve phase, improvement validation step, right? So likewise, we're going to combine the data from control phase with that of improve phase over here, right? So you could see this is the data. We're starting with improve phase and will be followed by control phase. So please do pay attention to this column. Well, let me use the pointer, right? So this column and this column, the column of phase and that of column of PT non-compliance, these two columns we will need, right? And please do remember this word improve is supposed to be in capital letters, and we are not supposed to have any space after this final letter of E. We need to ensure that. So use backspace after, once we type improve, please do use backspace so that there'll be no any space after the word E, after the letter E. So on that note, let's go ahead. Right, so this is the data which we do have improve phase data, which we collected in improve phase. Likewise, control phase data. Right now, the control phase data is following the improve phase data. Right. So this is what a data we do have. We clubbed both of these data together. And now let's follow the instructions. Here we do have few instructions. Use improvement stability data from previous 5 slides to execute two proportion test in two proportion tool shared with you all. From previous slides, not slides, copy data from the column of phase and PT non-compliance. We already talked about that because these are two important columns for us. So we are going to copy the data from column of phase and the column of PT non-compliance, and we are going to paste it in a tool, which we already shared with you. Again, this couple of small suggestions for all of us. Ensure to check data of phase column is in capital letters and there is no space bar clicked after typing word control or the word improve, right? So please, once you type the word control after L, please press backspace, and once you type the word improve after E, please press the button of backspace on your keyboard, right? And likewise, just do it for rest. You can just drag that word improve and drag the word of control across the sheet, right? So that's quite easy to do. So all we need to remember is we shouldn't be having any space bar, after typing the word control and improve. Then the instruction number 2, type NC in event type and um, choose this sign. This is a greater than sign by checking out the drop down given in a test type. So we need to choose this sign, which is greater than sign and not less than sign. So please do remember, in improve phase we use test type of less than, but in control phase we will use greater than. So we need to remember this difference. And finally, check the p-values, as simple as that. So on that note, let's go ahead to the next slide and check it out how it goes. Right. So this is what the snapshot of two proportion validation test. Here we pasted the data of improve and control together, phase over here, and the project wise C and NCPT non-compliance over here. Once that is done, we need to ensure that event type is NC, capital NC, and in test type, we'll just choose the drop down of greater than sign. And once that is done, we will get this graphical representation. We'll get this table as well, and of course, importantly, we'll also get this p-value, which is 0.6210, and this is greater than 0.05, and that is what we wanted. So inference over here, p-value is 0.6210. It is very much higher than 0.05. That is what we wanted. Thus, we fail to reject null hypothesis. Hence, we can conclude that performance of the control phase is same as that of improve phase. That's what we wanted to do. In other words, we can conclude that improvement is stabilized in the control phase. So with the help of two proportion test, we are going to validate the sustenance, or for that matter, sustainability and stability of the improvement in a control phase. In other words, we can say that problem is fixed for a permanent basis. So this is what we do expect to do with the help of two proportion test. Now take the data live and do it live so that we'll be able to understand, right? So let's do it together. So I'm going to show it on a spreadsheet how we're going to take the data the way I used to do always, right? And I'm going to paste it in a tool and we can see it together. So let's go to spreadsheet and start doing it. So we are on a spreadsheet. Here we have copied and pasted improve phase data and control phase data together. And we have seen this data on our slides as well. So all we did is whatever improve phase data we had, we just copied and pasted it over here, and followed by control phase data. This is the improve phase data, right? And this is the control phase data. So we pasted it over here. And as instruction goes, we need to pick this column and we need to pick this column. These two columns are essential for our for our test, right? But prior to that, we need to ensure that the word improve and the word control are in capital letters and there is no space after the last letter in that particular word. So here in this case, there shouldn't be any space after the letter E, right? So we are going to copy this and let me check right here. So copy this and I'm going to paste it over here. Right, so I do have an improve phase data and control phase data. Let me check whether there is any space bar. So all I'm going to do is I'm going to retype it in capital. Improve, right? So there is no space now. I'm going to enter and then I'm going to paste it until I do have the word improve. I'm going down and down and down until we are finishing with the improve phase. Right here up till here, I'm going to paste it. Once that is done, I mean, you don't need to do it every single time, right? But if that space is there, then only we need to take care. Otherwise, there's no issue. But what I'm doing is I'm just, being extra careful to avoid that error, right? That's what I'm doing it, and I'm showing it to you how to do it, right? So I'm going to type the word control again, right? So there is no space after the word control now. So I'm going to enter it, right? So I'll take this word control, copy it. So I'm going to copy this word and I'm going to paste it over here. You can drag it or you can paste it. It's totally up to you. So dragging and pasting is also the same thing. So I'm going to drag it or paste it rather. I'm going to paste it. So for all those who don't know much about Excel, right? So I'm just going to paste it over here. So now I do have a data ready. All I need to do is I need to select data from here and not from the titles, right? From here, improve and control phase data, both together for two columns. I'm going to copy it, right click, copy it, and then I'm going to go to our tool of two proportion test, right? So here we do have a different sheets over there. One for improve versus measure, and this is for improve versus control. So we are going to choose improve versus control sheet, right click, and we're going to paste it. This is where, and this is how we have pasted it. See, you could see there's some error here, right? This is 0. Why is that so? Because there's some space after the word improve. Let me do this correction again. Improve. And then I'm going to enter, right? So this word I'm going to copy and I'm going to go down until I do have an improve phase. I mean, that's quite possible, after copying there are some you might type some or you might click on a bar key and there's a possibility of getting that space. So that's quite normal. Right, so now here we got observations 90 and 126. Oops, but here we do have 0 numbers, so we are not able to see the NCs over there. Why is that so? Because we haven't yet typed NC here. So capital N and NC, and we're going to use the test type of greater than. So we did it, and bingo, here we got a p-value, here we got table, and of course the comparative graph as well. And since p-value is more than 0.05, it indicates that we have sustained with the improvement. We fail to reject null hypothesis. We want null hypothesis to be right, and that's what we could see with the help of statistical assessments. So all I did is I just took a snapshot from here and I have pasted it in our tape. right? So this is what the date we do have. So here we pasted it, and that's it. This is what we need to do. So this is how we are going to prove that improvement is sustained or stabilized in a control phase. In other words, it indicates that the problem is fixed permanently, right? There is a possibility that the problem can resurface in the future, but for time being, right now, the problem is completely fixed. So that's what we do have into this two proportion validation test. I hope you understood how to deploy this particular test, and most importantly, if there are any errors which you could see here, we saw that zero here, right? All we need to do is we need to just ensure that there is no space. If you could see zero over here, or for that matter here, it's only because of that space. But if you could see zero here, here, and here, it's because you haven't added NC over here, right? And please do not forget, after adding NC over here, we need to choose the test type of greater than. So just click on a drop down and select the test type of greater than sign. That's it. So this is what a two proportion validation test is for us. And this indicates that we have sustained the improvement or stabilized the improvement in a control phase. So let's go to next slide. Right, the quiz time. In control phase, we favor null hypothesis as we want to prove control phase performance is same as improved phase. Hence, we expect p-value should be more than 0.05 for 2p test in control phase. True or false? We already talked about it right now. The answer is absolutely true. We want p-value to be more than 0.05. Let's go to the next slide. Yes, so here we are done with validation of improvement or sustenance, especially with the help of 2p test. Now we're almost done with this particular video. In upcoming video, we are going to check the capability analysis of the control phase, the way we check capability in an improved phase, and that in a measure phase, we need to reconfirm that capability has also been sustained in a control phase. And of course, I already talked about that we also need that P chart again. So why we do need that P chart, we're going to look into it in details in our next video. So this is what we do have in a next video, and then of course we need to submit the documents again to the authorities, and we have the documents of improvement with the help of Six Sigma project. So we are going to showcase this date, the presentation to them, where you're standing at defined phase, then in measure, and then analyze, and then improve on that control phase. And then once that is done, that's it. Final thing, which we're not supposed to forget to do, is to celebrate. That's what we are left with as far as DMAC methodology of problem solving, or for that matter, Six Sigma implementation is concerned. So let's meet up in the next video, where we're going to cover all these things. So, but before we end, thank you so very much for your time, for sparing your time, on this particular video. If you like the video, please click on the like button. Please do share the video with your friends, and of course, please do subscribe to our family's channel, YouTube channel, the Breath of X YouTube channel, if you are not yet subscribed. So on that particular note, Uttishta Bharata, Ma Bharati shall rise again in a full glory. And before we end, as we normally do, let's thank technology companies for their support. We deeply appreciate following technology companies for their technological support. By the way, when I'm saying we, it means you and me together. So on that note, yeah, we're thanking them. Great. So let's meet up in the next video, and we'll continue with the control phase, and we'll finish the control phase by the next video. So On that note, thank you so very much for your time. Please do take care of yourself and let's meet up in the next video.